bring in AIVOT. And AIVOT was introduced to me by, was it the Tech Bridge? Was it Johan?
Yeah.
Yeah, so this was the Mission Acceleration Center, which is part of NavalX and the Tech Bridges. They were the ones that introduced us and thought that this would be a great presentation for this forum. I really like this because I'm not a coder, I'm not a computer programmer kind of guy, and man, if I could program a robot and teach a robot just by talking to it, that is the way to go. So with that, I'm going to turn it over to AIVOT to go ahead and let you know what it is they're doing.
Thank you, Eugene.
Go ahead.
Thanks. Hi, everyone. I'm Shah Srivastava. I'm the CEO and founder of AIVOT. Thanks for attending the presentation. So AIVOT builds intelligent humanoid robots. These robots can move around autonomously and navigate on their mobile basis, and they can perform dexterous tasks with their 2 arms. They can understand the human spoken language, and that's how they learn new skills. They can observe human demos, and that's another way of learning human skills. It's a very vision-based system, so it can look at surroundings and it can be commanded, instructed to do a certain task by giving them the voice commands. Like I said, that it basically understands the context of the task. It looks at the environment around it, and then it generates the plan on the fly in the real time to act and accomplish the goals that are specified. It can also be instructed to keep humans in the group, so they can communicate with the humans operators, and at strategic points when certain conditions arise and get a confirmation to go ahead or do something else. So all the processing happens on board, so there's no network or internet connection required for them to work. So that was a quick, a brief summary of what we do. I go deeper into each of those things. As Eugene mentioned, that our main aim in participating and getting the feedback is that it is a versatile technology, but where should we think about deploying it? What are suitable matches? So like, I'd really appreciate your help in figuring that out and getting us some introductions for potential customer pilots. So the problem with the robotics, sorry, before I start, like, another thing is that I intend to keep my talking time to less than half of the allotted time. So please feel free to interrupt at any point, and we can have discussions. And also at the end, we can also have more discussions about the deployment possibilities. So with that, I dig deeper into like how the system works. So the problem with the robotics today is that they have limited scope and they do not scale well. So they are implemented for one specific action, and that action works if the conditions are predictable. And like, it takes a lot of resources to implement and build automation for those scenarios, which requires technical expertise. But if there is any change in the requirements, like change in the workflow or change in the object that has to be manipulated, the re-implementation has to be done for the automation. Often the workspace has to be modified, so you have to bring in conveyor belt and those type of things to make automation work. So it's not flexible in that sense. What we've done is, like, we've built an integrated robotic end-to-end solution that can perform unstructured task in and complex task in dynamic and unpredictable environments. And we've built a form factor which includes the hardware and the software as an integrated thing, so that it can just be deployed as an out-of-box by layperson operators and made to work in any situation. However, the core value prop that we have is in our software, the AI-based software, and the software itself is hardware agnostic. So basically, it can be made to work on any off-the-shelf third-party commercial robotic systems like industrial RAM, cobots, AMRs, unmanned vehicle, and so forth. And they work by like the software works just by integrating the configuration of the hardware, and then it is able to talk to the low-level motor commands with the hardware and bring in the overall intelligence to the system. We've shown few examples of how that's done in our deployed systems, and I'll talk about that a bit too.
Right. Let me interrupt here for just a second. So, Ed Hendricks, did you have something? It looked like you unmuted. Did you have a question?
No, I do not have a question.
Okay, just wanted to check just to make sure. So
Okay,
one of the
no
key
worries.
things here, that I wanted to highlight is the fact that this works in a dynamic environment. And a lot of times when you're programming robots and Shashwat will go into this, but things need to be in specific places. And one of the things that I saw about this robot and their system here is that you don't need that. That requirement is not there. So if something gets moved, the robot will still be able to find it, even if it isn't where it originally expects it to be. So I just wanted to interject that here. Sorry.
Yeah, that's a great point. And that's why it's the use cases where this robot, the value prop where this robotic system shines is in more of those environments where we can't put things in a structured manner, or we can't arrange them on a conveyor belt. So that's why defense is one of the key areas that we want to focus in, because the automation has to be done in a more unpredictable, unstructured environment in those cases. So I'll dive a bit deeper into how the system works, the software system. So basically, out of the box, like as I said, it's a vision-based system, so it can detect objects, it can track objects in the real time. It uses a variety of deep learning models inside the system as building blocks. Out of the box, the robot comes pre-trained with identification of common objects, and so it understands what table, chair, glass, all these object means. It comes with a natural understanding of the language and the description that people use to define various tasks of workflow. It also comes with an ability to perform basic everyday actions. So like, what does lifting mean? What does grasping or placing something on top of another thing? How do those things work? So like ability to manipulate rigid objects, it has an understanding of that. So basically, just out of the box for a robot, I can say that pick up the green box and place it on top of inside the packet, and it would be able to do that. But oftentimes, like people have unique objects and tasks that they want to automate. So in that case, they can show the object to the robot and say, I'm going to teach you about this new object, and this is the measuring instrument. Let's say that we want to measure the radioactivity level of something. So we can say that this is the object that I want you to learn about, and you can show the object in front of the robot so that it can see its shape and texture. And then you can say that this is a special point on the robot, and you can show that this is the button that I want you to consider. And you can name all these concepts. So you can say this is the start button, this is the measuring instrument, and you can also show it a pose that to measure, you have to bring the object in this pose in relative to another object, and it would understand that. So now once you've named all these concepts, you can describe the overall workflow. So you can say that pick up the measuring instrument, bring it in front of the table or on the door, and press the start button. And on the display panel, read the numbers and tell me what it is, or record it, or take some action based on that. So this is how you would configure it to do certain tasks, and it has a reasoning ability in it. So like you can also build up the workflow in the way that if you see this, then do that, otherwise do that, and if this happens, then go and do other things. And once a robot starts producing, like performing these tasks, the operator can also give a feedback that the measuring instrument was too far away from the door, bring it closer. So it would understand the context in which the feedback is given, and it would improve that particular action and repeat it. Once the robot has done that thing and operator is satisfied that, yeah, this looks good, they can commit the skill or save the skill on board on the robot and name it that this skill is called measurement on door skill. And then they can use that name of the skill as a building block in a higher level flow. So they can say that go and explore the indoor environment, and if you see the door, follow the measuring the door scale, and you can build up in that particular fashion. So I pause a bit and see if there are any questions on those concepts. Okay, so I also wanted to take a moment to show a video of the things that we talked about. So basically, this was just a toy example recorded earlier to show the concept. So this is out of the robot. It has no training on these objects. So like it is just working off its common understanding of different things, and it's able to follow those instructions and perform those tasks. Between the spoken instructions and the thing, there is a pause of like 20-30 seconds, just because it's processing and creating the plan and trying to learn. And in that video, in this video, that pause is cut out. That was improvement. After picking up the orange cube, move it 10 centimeter to the right and 10 centimeter up before the next step. So it is a more the interaction is more conversational with the robot. So you can give it a feedback. If you use something that the robot doesn't understand at all, it can say that I don't understand this. Can you explain? And that's how you can build up the skill and refine the skill as it goes on. Fix the object with the word "think" on it and place it on top of the robot. Okay, it can. So this is a think bar, but it can read the words and make sense out of it and take decisions on that basis too. So the other one thing I wanted to show was the learning by demonstration. So this is like what I described, that how you show the flow. But here the robot is tracking the human hand, and once it comes in contact with something and it starts moving that object, it begins tracking that object that was moved. And the robot has 3D cameras on it, so like it can understand the shape, pose, and those things too. And like if that object comes and it starts interacting with another object, it starts tracking those objects too. And in this way, it builds up the whole context on the task that needs to be performed. And once that context is built up and it understands the task context, then it can be given an environment where things are arranged in a different manner. There are other objects in there, but it would still recognize the objects that were there in that original task description, and it would build up the context and perform that action. So this particular robot was a prototype that we had built earlier. This is our own hardware prototype. And I'll talk about hardware later, and I say why we built this robot. But as Eugene was mentioning, things can move around. It can react to that thing and on the fly and perform that action.
So this is Eugene. Would you be able to provide those videos so that we can put them in the document repository, or put links in the chat here where people could actually access them and watch them? Because they may be a little choppy here with the presentation. Yeah, so I paste the link in the chat. This video is on our website, so but I write it down. Thank you. And so this was we had deployed the robot in a commercial kitchen in Pacific Northwest at Evergreens. It's a chain of 32 restaurants. And they basically had the to-go salad boxes, and the robot did a pilot to pack the to-go boxes, where it picked up the bowls from a stack of bowls one by one, and it packed the greens in those bowls.
It's completely unstructured. The stack of the board moves as it's being manipulated, but the robot is still able to adjust to that. And the humans, they pick up the board and arrange the toppings on top of that. Another task we automated for them was the production of the bottles, beverage bottles. So a person brings in a tray of bottles, which are all unstructured in there. If one bottle is picked up, others moved. But the robot detects bottles and picks them one by one from the box. And it uses the labeling machine to put the label on the bottle. This required some precise coordination for it to be able to do that. And it read the text on that label to know when to stop labeling. Some other videos we've done is these are more of our demo videos inside our office to show the capability of the system itself, where like it can go back and forth and fetch, pick up and move boxes. Sorry, that video was cut short. But anyways, like it in the original video on our website, you see that it also goes back and forth and picks up all the like different shapes and sizes of objects, like envelopes, small box, and so forth. And it's not a precise back and forth motion, but it is able to locate those objects and figure out how to pick them and bring it in the front. We had done some other targets to do to-go boxes, packing, again to show the versatility. And like this is an example where we said that go along the floor and pick up the toys and put them in the bag, and it's able to explore and find objects on the floor and pick them up.
So are you using tactile sensors in the fingers to be able to prevent from crushing and sensing the objects that you're touching and grabbing? How are you handling that?
Yeah, so we haven't done it that yet, but yeah, that is a plan. That is one of the things to integrate in these robots. Basically, like what we do right now is that we have various multiple levels of the force, and the operator can say that start with the right grasp, or this object is heavy, used heavy like tighter grasp. So we require more of operator input right now, but yeah, that is in the plans to develop.
Okay, real quick, Michael, can you turn off your camera, please?
Okay, so
all right, so no, good to hear. So then what you're doing is you're basically predetermining the force that is the maximum that it can use, and then just allowing that to be in the programming.
Yeah, so basically, like we have 3 levels, levels of force that the gripper can grasp, right, medium or hard, and the operator can say that start with the right force or start with the heavy force, and those predetermined programmed grasping levels is the robot uses that.
Okay, thank you.
So basically, like we on the hardware side, we've worked with integrating our software with various different hardware, Universal Robot, Fanuc, and ClearPath Robotics, mobile base, and so forth. But we've also developed our own prototype hardware where we've put a form factor of mobile base and 2 arms together. And the reason for doing that was that like the hardware that is in the market right now, they're very high precise and integrate components. So they can follow a precision path up to 0.1 millimeter accuracy. But with vision and AI systems that have been developed, what we've done is that we used low precision sturdy hardware components, and we course corrected and brought in the precision using the vision and AI software itself. So we moved the precision up in the software. So if the imprecise hardware is taking the arms to certain path, the vision and AI would use the closed loop to instruct the hardware to course correct as it's moving on. So the prototype that I showed in the video, we developed that to show that the task can be accomplished using that design principle, and the hardware cost reduces to 1/10 of the one available in the market using those principles. So we've done the prototype development, but we haven't done we haven't started the production of that hardware. We wait for our pilots to get over before we do the final design for that. So on the whole, the value propositions that we have for customers is the ease of automation, that they can deploy the robot using natural interfaces, the task complexity, that because of vision AI, it can do more complex tasks, and increased autonomy, that no one has to teleoperate for more complex scenario, and the robot would be able to go and do things on their own. So we want to focus on defense.
Can I stop you here again? And
Yeah.
I don't know if you're going to get into this, but are you going to cover the different products that you offer, or
Yeah, so basically,
you don't just offer the robot with the software, you offer the software separate, correct?
yeah. So we have an offering. We've started. So our software development is complete, and we have started putting that into the production. So we offer a software-only offering where we can deploy our software on any hardware that is suitable, and that we lease out for $960 per month for one per robot, and that's the only offering we have right now. That is ready for customer deployment, and hardware would come in later after a year or so.
Thank you.
And that also offers us a flexibility, because like in many of the defense scenario, some of the robots have to lift up 100 pounds, and the normal sized robots are not going to be good enough for that. But we can put up industrial arms which are huge enough to lift 100 pounds. And which are manufactured by established players like Fanuc, and we can put our software on top of it to add the intelligence aspect to it. So we are focused on defense scenario as our main market, because that's where, as I said, the value prop of the system would shine. Logistics is field logistics is one use case that we think it would be useful in, where it can bring in supplies to the soldiers who are on the front as required. The chemical and biological testing, CBRN use cases is another use case that we think it would be useful in. In fact, we are attending an event called Tenacious Dragon that is organized by Defense Threat Reduction Agency in Camp Burris in Texas. And we'll go there in July to demonstrate the system for CBRN related task. EOD is one thing that we are very interested in. We haven't started any engagements now, but we are very interested in looking at EOD use cases for the robots. And other than that, it can just do support on a variety of mundane and repetitive tasks. Some of the other use cases we can think of is repair and construction, surveillance technology, terrain shipping, and so forth.
So when you're talking about, so your robot is autonomous, does it have the option to be ROV? So, especially like in an EOD environment, it may come across something that you haven't been able to teach it, or there may be a certain process that, for a device on how to remove a cover or whatever. Is there a way that you could interface a human being so that they can see what the robot's seeing and interject in situations that are dynamic or are not previously understood?
Yeah. So basically, the view can be visible in whatever the robot is seeing in the camera, that can be relayed back to the human, and people can interject at different levels. They can instruct the robot to to have them involved at many levels. So basically, they can say that go and explore the room, and if you find this device, tell me. So basically, the robot detects that device. It can ask the person, what should I do now? And the person is looking at the screen, and he can either say that, go ahead and pick it up, or he can also say that move your arm 10 centimeters to the right, 10 centimeter to the left, and close your grippers and close your this thing. So the entire interaction is conversational, and so the conversational can be that go and do this, or it can also be at a specific motion level to say that move this to 10 centimeter, open your gripper, and so forth.
I thank you for elaborating on that.
Yeah, so on the defense side, like we are trying to talk to different agencies and find the use cases. We haven't started any engagements, formal engagements yet, and there are these experimentation events that we are participating in. We are also going to go to a USL conference and the Air Force conference, and we demo our robot live in those conferences. So that's our progress on the defense side. On the commercial side, like it has multiple use cases, so it's a dual use technology, and we are working with some of the select customers for pilot opportunities in the manufacturing sector, where we are automating their high mix and low volume tasks. And more unpredictable task. So we're not saying that replace your existing robotics, which are working fast and accurate on the conveyor belt with our system. We are saying that that there might be other miscellaneous tasks around your core automation, which has not been automated just because they are high mix and low volume. And this is where the system could come in and help with automation. So what we have actually done is like made it easy for layperson operators to deploy the robot, and the robot learns with that experience. And once the operator iterates with the robot and perfects a skill, then that skill can be used as a learning data for the overall system. And a skill learned by a robot can be deployed on another robot on that deployment. So overall, it increases the intelligence and the capability of the robot deployment. Like we've done the customer deployment as that shown mentioned in the Evergreens, and they were facing labor shortage issues, and the robot helped them in launching their beverage business. And this was the videos that I had shown. These are some of the other videos that we had seen for different use cases. We have a background in the B2B products, making them successful complex technology products. Right from the start into the market. And I was VP of engineering at EMC and an early engineer at Microsoft Azure. So that's the background. As I mentioned that our software development is complete. We do offer software only as an offering, and it is ready to be deployed on the robots in the field using off-the-shelf hardware components. We can configure the hardware based on the use cases so that it's suitable. And once we've done a few of these pilots, that's when we finalize our own hardware design and make it ready for production later. And then after that, we'd be able to offer another offering in addition to the software only, which is like the integrated robot. This is my contact information, shashwat@ivot.com. And I'd love to have more opportunities to collaborate on different projects and pilot opportunities. But yeah, that was for the presentation, and we can have more question answers or discussions.
All right. So anybody have any questions for AIVOT? Howard?
None here. Well, I guess are you? I listened to everything. I'm just trying to remember if you said you were doing any current military work right now.
So we are not doing any we don't have any active engagement with defense right now. We are very interested in doing that, and we are trying to have conversations and start the engagement. We are participating in an experimentation event by DITRA for a CBRN use case in Camp Burris in Texas. We did an experimentation event at GIFIX in Camp Roberts in California last month. But yeah, we are at a stage that we are going and doing experimentation events and demos, but we are very interested in starting an active engagement.
Thank you.
Okay, so I've got a few questions unless someone else has something. So if you teach one robot, can you transfer that to another robot? And then maybe if you're looking at, let's say, an assembly line with 5 processes, could I teach all 5 robots to do all 5 processes so that if maybe something were to happen to one of my robots, another robot could pick up the slack?
Yeah, yeah. So basically, like these skills are like named skills with and they are like procedure invocation. So basically, like you can teach a robot skill A and say that go and do skill A, and then you can tell that robot that stop, now go and do skill B. Uh, you can also tell that robot that I have an assembly line. If you see object A, then perform skill A. If you see object B, perform skill B. And that robot will be able to invoke its procedures as this comes along. And now you've built a repository of skills that can be stitched together in a higher level skill too. And this repository of skill can also be transferred to another robot, so you can give them an instruction that all of 5 of you are working in different positions in the assembly line. If you see object A, do skill A, and so forth. So yeah, it's a building block arrangement.
Okay, so have you talked with anybody at Defense Logistics Agency at DLA?
I had one conversation with a program manager, but I haven't heard back. But yeah, it would be interesting to have more conversations with them.
Okay, because we're tied in with DLA's research and development arm. And if they weren't on here, I'm going to go ahead and forward this to them.
Yeah.
So keep an eye out.
Yeah, DLA is a very interesting because like the type of things they do. So yeah, that introduction would be very appreciated. Thanks.
Right. Now, what about the Manufacturing Innovation Institutes? Are you familiar with those?
I'm familiar with ARM and NCMS. I haven't heard of Manufacturing Innovation Institute.
Okay, so these are like quasi-government manufacturing institutes. They focus on different things. One of them that's actually, they have an office here in Tampa, that is the Advanced Robotic Manufacturing Institute. That would also be a good contact that we need to be addressed.
Okay. Okay, so yeah, that would be very helpful to introduction to them.
Okay. So did you have anything more you wanted to add?
No, that's all from my side.
Okay. Does anybody in the audience have any questions before we wrap this up? All right. Well, I'm not hearing anything. So I want to thank Joshua for this presentation. I think this is a phenomenal capability. As far as robotics go, the coding is always time consuming, and I like the idea. I like this approach. Like I said in the beginning, I believe that this is an interesting way to teach, is through visual, through verbal, because this is how we as human beings learn. Nobody programmed us. They teach us. So I see a lot of applications for this. Please, again, share it with your peers, share it with your commands, share it with your companies, and let's see where we can take this. I appreciate everybody's attendance. I appreciate AIVOT and Silver Thread and Biosortia. That will wrap it up for this week. Thank you all, and we will be back again next Wednesday with 3 more presentations.